In this video, we look at some examples of large language models. We get into the details of three state-of-the-art LLMs, Palm, LaMDA, and GPT. And we will also discuss some other LLMs which have shown promise in the field of generative AI. So let's start with Palm, which stands for Pathways Language Model. Palm is a 540 billion parameter language model developed by Google AI. It is trained on a massive dataset of text and code and can perform a wide range of tasks, including question answering, natural language inference, code generation, translation, and summarization. It utilizes Google's Pathways system, which enables it to be trained on a massive dataset of text and code. With 540 billion parameters, Palm is one of the largest language models in the world. It is a dense decoder only transformer model, which means that it is specifically designed for natural language generation tasks. Palm can achieve state of the art few shot performance on most tasks, which means that it can learn to perform a new task with only a few examples. This makes Palm a powerful tool for a variety of applications. So, what is Pathways System? Pathways System is an AI architecture that stays highly effective while generating across different domains and tasks. It is able to effectively train a single model across multiple TPU v4 pods, which are Google's custom designed machine learning accelerators. This allows Pathways System to handle many tasks at once, reflect a better understanding of the world, and learn new tasks quickly. Pathway systems achieves this by using a number of techniques, including model parallelism. This technique allows multiple models to be trained on the same data simultaneously. This can improve the training speed and efficiency of pathway system. Data parallelism. This technique allows multiple copies of the same model to be trained on different datasets. This can improve the accuracy of pathway system by allowing it to learn from a wider variety of data. And auto machine learning. This technique allows pathway system to automatically optimize its training parameters. This can improve the performance of pathway system by preventing it from overfitting to the training data. Pathway system is still under development, but it has the potential to revolutionize the way we build and deploy AI models. By enabling models to orchestrate distributed computation for accelerators, pathway systems can make it easier to build and train large, complex AI models that can handle a wide variety of tasks. Next, let's discuss Google's another LLM, LaMDA. LaMDA stands for Language Model for Dialogue Applications. LaMDA is a family of neural language models developed by Google AI. It is trained on dialogue and has up to 130 billion parameters, pre-trained on a dataset of 1.56 trillion words. Lambda has three key objectives of quality, safety, and groundness. These objectives are measured by metrics such as sensibleness, specificity, interestingness, and informativeness. Lambda is designed to be informative and comprehensive, while also being safe and grounded. It is able to generate different creative text formats like poems, code, scripts, musical pieces, email, letters, and much more. It will try its best to fulfill all your requirements. Lambda has the potential to revolutionize the way we interact with computers. It can be used to create more natural and engaging dialogue experiences, and to provide users with more helpful and informative assistance. As we said earlier, there are three key benefits in Lambda. One, natural and engaging dialogue. Lambda can engage in natural and engaging dialogue with humans. It can understand the context of a conversation, and it can respond in a way that is both informative and interesting. 2. Helpful and informative assistance. Lambda can provide users with helpful and informative assistance. It can answer questions, generate creative text formats, and follow instructions. And 3. Safe and grounded. Lambda is designed to be safe and grounded. It is trained on a massive dataset of text and code and is able to distinguish between safe and unsafe content. And now let's move on to OpenAI's GPT, which is short for Generative Pre-trained Transformer. GPT is a type of deep learning model used to generate human like text. It was developed by OpenAI, a nonprofit research company, and is funded by Microsoft. GPT utilizes a transformer architecture, which is a type of neural network that is well suited for natural language processing tasks. The parameters for the latest version of GPT, which is GPT-4, are undisclosed, but it is likely much larger than GPT 3.5's 175 billion parameters. This means that GPT-4 has a greater capacity to learn and understand language. GPT-4 has also shown to be proficient at skills assessments such as the BAR exam. In a recent study, GPT-4 scored in the 90th percentile on the BAR exam, which is a standardized test that is required for admission to the bar in many jurisdictions. GPT is a powerful tool that can be used for a variety of tasks, including generating text, answering questions, translating languages, and much more. In addition to what we discussed so far, there are other LLMs that are transforming how we look at AI and are helping shape the future of the field. Let's briefly review some of them. The first one is Turing NLG by Microsoft, a large-scale language model trained on diverse internet text that is capable of writing coherent paragraphs and even whole articles. BERT by Google, a revolutionary transformer-based model that is pre-trained on a large corpus of text and fine-tuned for various natural language processing tasks, providing a high level of understanding of context and semantic meanings. Transformer XL, a language model developed by Google's Brain team that innovatively handles long term dependencies in sequences, significantly enhancing the performance of tasks like text generation and translation. There's also XLNet, which is an extension of Transformer XL developed by Google Brain and Carnegie Mellon University. It uses a permutation based training method to overcome some limitations of BERT and outperform it on several benchmarks. Electra is a highly efficient pre training approach developed by Google Research that uses less compute power for similar or even better performance than models like BERT. We have Megatron Transformer, a transformer based model developed by NVIDIA designed to train very large language models with billions of parameters. It leverages parallel processing capabilities of modern GPUs. And we have Llama. Introduced by Meta, Llama is a foundational, smaller, yet performant large language model. It's designed to broaden access to AI research, requiring less computational power and resources for testing new approaches and validating existing work. Llama can also be available in different sizes, ranging from 7 billion to 65 billion parameters. So, in this video, we dived into the exciting advances in large language models, focusing on Google AI's Palm and Lambda, as well as OpenAI's GPT. We also highlighted other noteworthy models in the field, such as Turing NLG, BERT, XLNet, and Megatron Transformer. We discussed how these LLMs, with parameters that can reach hundreds of billions, redefine multitask learning and revolutionize our interaction with computers through engaging dialogue. These models have already demonstrated their exceptional abilities in tasks like text generation and even practical assessments like bar exam. And they only keep getting better.